Okay, so exercises for Chapter 8. The first one is asking us to write a function, print triangular numbers, that prints out the first n triangular numbers. So a call to print triangular numbers 5 would produce the following output: 1, 3, 6, 10, and 15. So the first thing we should note is that this is going to be a noisy function because it says right in the name, print triangular numbers, and it says that calling print triangular numbers 5 will print the numbers, so we don't have to use a print statement. It's going to be a noisy function, so instead of returning something, it's going to print something. So that's the first thing we need to know. The second thing we need to know is what is a triangular number. So if you don't know, a triangular number is essentially the number of objects that would form an equilateral triangle. So for example, the first triangular number is 1 because one object makes a triangle of one thing. 3 objects makes a triangle of 2 layers. 6 objects makes a triangle of 3 layers. 10 objects comprise a triangle of 4 layers, and etc., etc., etc. So if you're wondering yourself, how can I represent that? Well, the answer is, thankfully, Wikipedia has the actual formula for us right here. So, unfortunately, we can't use their final version of the formula down here because I do not know how to represent binomial coefficients in a programming line. That may be possible. I have no idea, but it does give us also the kind of second to last step before we get to the binomial coefficient, which is this expression right here: n times n plus 1 over 2. So we need to do n times n plus 1 over 2 for each number that we put into this function up through n. So let's start with our definition. So print triangular numbers n, and it is a function that prints the first n triangular numbers on their own lines. Okay, so we're going to use a for loop because this is a definite iteration. We know how many times we want to iterate through this. We want to iterate through it n times, so we want a for loop. Now we can't just do this. Why can't we just do for I in range n? Why can't we just do that? The answer is, of course, that if we do that, it's going to take us not 1 through n, it's going to take us 0 through n minus 1. So instead, we want to initialize our range function at 1, and we want to end it when we get to n plus 1. So in this case, it's going to go 1 through n plus 1, exclusive, meaning it's going to do 1 through n. So for I in range 1 through n, essentially, 1 through n inclusive, we want to then print, and go get our code here. Okay, our formula is n times n plus 1 over 2. So we'll just type that out. We want to print n times n plus 1 divided by 2. So that let me run my order of operations here. So it's going to add these together, multiply it by that, and then divide it by that. Okay, so that should get us the right answer. Whoops. Not if I don't make a call to the function. So print triangular numbers, and let's do 5 like the example asks for. Okay, that's wrong. Why is that wrong? Because I used n instead of I. I used n because I was just copying the formula from over here. But in actuality, I should have used I because that's my iterator. There we go. So 1, 3, 6, 10, and 15. Now, you'll notice that this isn't the same as the output up here, and that is because what we're printing out here are float numbers, floating point numbers, because we're doing division and multiplication. So we're implicitly casting these ints up here into floating point numbers. So if we wanted to work around that and put them back into ints, all we just all we have to do is just include a call to the int cast function. So there we go. Cast them back to ints, print them out. We get 1, 3, 6, 10, and 15, and we can print, as many of these triangular numbers as we want. And it should just work.